Record to the cloud. All right, so I'm recording this just so if you guys want to go back and watch this after the fact, you can. Today we're going to be covering computer-aided manufacturing and the CAM tools that exist inside SolidWorks. This will allow you to run really any machine tool that you configure inside SolidWorks to manufacture parts. So this is kind of like a direct from 3D to production pipeline. And therefore, there is a lot of things to consider inside these packages. We're not going to go into most of the tools in here in detail, but I'm probably just going to give you guys enough information to be dangerous. And my goal is for you all to be able to generate a G-code file that I run on the Carbide Create, which is our 3D engraver over in 335 to personalize something. So the example that I'm going to use is my phone case. And so I'm going to put some lettering or something onto a block. I haven't really decided yet. And then we'll go through the process of making that. And then I'll actually put it out on the machine. At the end of class, I'll put it on the Create and you guys can see it run and it'll cut out that path, right? I'll try to keep mine pretty simple just for the sake of it not taking too long for it to cut everything out and keep my Toolpaths fairly straightforward. And I suggest you guys do the same. And then if you want to add more complexity before you submit your files by the end of the day today to make something more fanciful or whatever, right? You can do that. You know, if you decide that you want to submit the assignment for the sake of submitting the assignment, but you don't want to actually engrave anything, that's fine. If you want to submit the assignment and then engrave something else later after you've had more time to look at it, that's also fine. Just let me know. Sound good? The advantage of the engraver is that other than toolware, there's no material use besides what you bring. So if you bring me something you want to engrave, you know, as long as it's not like steel, it's got to be a very, very light metal, like very, very small amounts of reduction in like brass or aluminum or plastic or foam. And again, not very deep cuts because we can only do, I think 6 inches is the travel of the head, but you also got to watch out for collisions. So we'll talk about that as well. Any questions before we get started? I would suggest you all download this SolidWorks CAM document. This is kind of like the walkthrough piece. You're also going to need to download this Carbide 3D GRBL control. This is the post processor that will allow you to export the G code in the format that is expected by the Carbide Nomad 3 or 883, which is the machine that we'll be using. SolidWorks has a couple of post processors in the setup by default for common machine tools, although I would be real careful that you check with your manufacturers and make sure that whatever post processor you're using is the one that they want you to use, right? So just like last time when we used the Cura software with the Ultimaker flavor, each of these post processors is going to have their own kind of implementation. Some of them are more standardized than others. Just make sure that whatever machine you're using the appropriate post processor. Otherwise, you may run into issues where the commands don't run properly and you can break things, right? Most of the time, you'll be breaking your work or your tools, but you could also break the machine if you run the machine into itself hard enough, right? Which could be a $100,000 mistake if you're doing it in production. For ours, it's like a couple $1,000 engraver. It's not that big of a deal, but so also I don't think it has enough power to actually hurt itself. If I unzip or if I get to this Carbide Create file after it's downloaded and open it up, these are the files I'll need for the post processor. It's got some instructions and stuff like that as to where this should go and the settings you should use. We're not going to look at that, but we do need to make sure we put this into the CAM folder for our SolidWorks installation. So you're going to need to go to your program files and find your SolidWorks CAM folder. On my computer in my office, it was in Program Data, SolidWorks CAM Post Mill. So this is C, this is SolidWorks Corp, SolidWorks CAM. I guess that's probably not the right thing. Let's go to C, did I say Program Data? That's why I need the thing here. Program Data, SolidWorks, you go to C. I don't have program data. Why don't I have, is it in users? No, C program data SolidWorks. Things are, so let's take SolidWorks data. No. I'm gonna go to program files and I'll look for, again, I'll look for SolidWorks. Maybe I wonder if it's because I've never opened SolidWorks CAM on here. Let's try that. I'm gonna open a new file.
SolidWorks data, right?
Yeah, but that didn't have any of the CAM files that I was looking for. So I went to see the SolidWorks data here.
Okay.
On my other computer, it was in program data, SolidWorks. So I'm going to try loading up the
Program file SolidWorks.
I think it needs to be in the CAM folders. So I was able to find program files, SolidWorks Corp, and then CAM, but I don't see the post or the mill setup on here. I look at setup. Now I'm gonna look and see if I go to SolidWorks CAM. This is the tool we're gonna be using. And I'm gonna try and open up the, wait, where is my, oh, it's probably over here. Okay, technology database. Did I hit the wrong button maybe? Technology database. And I'm wondering if opening this up may have it go and kind of load in all those files into the database for me. This is what I'm looking for. But I do need to add those files to that database. Let's see here. I wonder if it's hidden. View. Nope. Of course. Look at my users file. We can still do the activity without having the post processor installed, but we won't be able to send it out to our Nomad. You know what? I'm just going to go ahead and I'll put it into. I'm looking into this folder real quick just to see if we have. There's SolidWorks PDM in there. That's not what I want. All right, I'm going to put it into the program data, and then I'll go to my SolidWorks Corp, and I'll go to SolidWorks CAM. Then I'm just going to make a new folder in here since I don't see any of the files that I'm really looking for, the NC files for the code. So I'm just going to make a new folder. Oh, is it going to let me do that? It's probably not going to let me do that. It's going to say I need admin privileges. Yep. Nope. All right, never mind. I'll just dump these files in here. I closed the zip file. Downloads. I'm going to open that up. I'm going to Control A to select all those, Control C to copy, come in here and Control V to paste. And see if it lets me do that. If not, we may be able to load in the post processor from the desktop or something, but it won't find it for us in the list of available post processors. Nope. All right, let's just put it on the desktop. Let's do new folder. I'm just going to call it Nomad. And then I'll put that in there. And then hopefully SolidWorks will let us pull that out after the fact. All right, so ooh, what's going on? Oh, that's my tool grip. So the first thing we need to do, again, we're going to run a CAM toolkit, is to make sure we have the appropriate post processors, which hopefully we'll be able to set up. This is the directory where I put the things in when I set up the lesson. I'm not sure where it's going to go if you don't have that directory. So we're just going to hope that we can set that up. The next thing we need to do is we need to define our machine in the technology database. We got to tell SolidWorks what kind of machine we're using. To do this, we're going to manually define a new machine inside SolidWorks. So I'm going to go into SolidWorks. I'm going to open up a part. I'm going to go to SolidWorks CAM, which I've already done all those steps, right? You might want to make sure your unit system is millimeter gram second. That's what I've set mine to. I'm doing that because I want to work in millimeters for my machine tools. If you want to work in inches, you can. But all of the settings I have are set up in millimeters. So just to be consistent, that's what I have that set up as. And then you want to come to the technology database. If you've got a kind of higher resolution monitor, it may just show up on the bar. Otherwise, click on the little arrows here on the right, and then click on technology database. It's going to take a second for that to load up. After it's loaded, the first thing you want to do is you want to select what type of unit system you're using. So just to be clear, like after I select my mill, my machine, I can't change my units, right? So the unit system and the machines are kind of separate. Like it looks like a toggle bar, but really if I open up and I make a inch driven mill, I can't change that inch driven mill into a millimeter driven mill. I have to make a new millimeter driven mill. Does that make sense to everybody? So make sure that if you're going to be making a new machine, you're defining it in the unit system that you want. To make a new one, I'm just going to open up the default mill. I'm going to double click on that. And it should open it here. I'm just going to give it a second. I'm trying not to be impatient here. I think I got it. Oh, not responding. See, I was impatient. It's trying. This may be where it's going to actually go through and make that SolidWorks data directory for me. And maybe why it takes a long time to respond. I don't know. It's not the kind of thing they tell you when you're trying to figure stuff out. After that's loaded, we are going to go through and we're going to put in the parameters for our mill. So I'm going to go into a double screen view here, just so I can do that a little bit more easily, since I'm waiting for this to respond anyways. So there's my mill opened up. I want to copy this one, so I'm going to click on the copy button. And it's probably going to take it a second for it to load that copy. There's my copy. I'm going to rename this one to Nomad 883. Again, you can give it whatever machine ID you want. Again, you can give it a description too. I'm going to put in all of the parameters that I want as far as the machine specifications. So I think I have the full list down here. So general here, I've made the description, ultra light milling machine. The post processor, again, I want to set this to the Nomad. I don't have that option right here. I can change the post processor after the fact, but just for curiosity, I'm going to go look and see if I have that program. Well, I still don't have program data. I'm looking at the SolidWorks directory and see if there's anything new. SolidWorks Corp, CAM. No, I still don't have that. I could probably look and see where these CTRL files are being located. Maybe I can find them with that. Star.ctl. Oh. Of course, it finds the one in my desktop right away. I'm just gonna let that search in the background, see if I can figure out what those are. I'll leave that just to a default 3-axis mill for now. And the machine duty, I'm gonna set to light duty. Ours were not even light duty milling, but that's the closest thing we have. I think that's all we need to specify in terms of the general specifications. I'll also make this my default machine, so that way it goes out when we do it. For my more specific specifications, the horsepower of this mill is ultra light. So it's about 0.1 horsepower. Again, it's a very, very, very light duty machine. I'm gonna set the maximum feed rate to 1,000 millimeters per second and the rapid feed rate to 2,500. Oh. Sorry, per minute, yeah, 1 millimeter per minute. These feed rates are very important because a lot of the speeds that the machine will use are going to be a function of these speed rates. Again, because this is a super light duty mill, these are fairly low numbers, but you want to make sure that these ones match relative to whether the kind of the properties of the machine are, right? Probably more important than anything else inside these settings. Horsepower also, because that'll help it kind of guide SolidWorks as to how it should kind of program the toolpaths. But a lot of the milling speeds are going to be a fraction of these values. So if they're too big or too small, your mill won't run optimally. If you want to start small and work your way up, if you're not sure what rates you should be using, that's a more conservative strategy than starting fast, right? So if I was really unconfident in this, I might even lower that down a little bit. And then once I realized it was going to take me 5 hours to print something out or to cut something out, then I would go back and ramp them up slowly. I'm going to set my travel to 200 millimeters in the X, which is about 8 inches, 200 millimeters in the Y, and then 76 millimeters in the Z. Again, very small table. And that's all I really need for the setup for the machine. So I'm going to save that. Yeah, I left it as the default because I'm not sure where that directory is being saved on this computer. Because it's in apps anywhere, it should still install a local copy. So we still have SolidWorks files on the computer. They're just not in the same spot they are in my local install on my machine. There may be like an apps anywhere folder somewhere inside the directory, or it may be hidden just the way that they have it configured inside here. Again, we can specify a different post-processor later in the process. So I'm hoping that we can just change it from the default for the machine to a explicit post-processor by doing that. And we'll see how that works. Hopefully it'll work. Maybe it won't. I'm still searching. I'm just going to let it keep going. Hopefully we can find that. Any questions on setting up the tool? Or really just adding this to the database? We actually haven't set this as our tool yet. So, all right, I'm going to close that. And I'm actually going to go into my model and make a part. I have my phone case is about 6 inches wide or 24, wait, no, sorry, I'm reading this backwards. 15 centimeters or 150 millimeters by 70 millimeters. So I'm just going to make a blank part that has about the same size as my phone. And you guys can make this, if you want to, if you know what you want to engrave later on, you can make it whatever you want. I just need something that I can use for a toolpath. So I'm going to say 150. And I'll make it 70 tall. Then I'm going to extrude this out. I'm going to make it just 10 millimeters tall is fine. The thickness of the case is actually a lot less than this, and I don't want my engraving to go all the way through. So I'm just going to use a fairly thin cut extrude on the top here. And I'm going to be lazy. I'm just going to use some text. So I'm just going to do Derek Lura. And I'm going to make that text nice and big. Mine was 170 or 150 by 70. Again, you guys can use different dimensions if you want. For me to be able to mill this, I need to make sure that the kind of the lines of my text are wider than my milling bit. So I'm actually going to make this pretty tall. Maybe not that big. That seems a little bit excessive. Let's do 18. That looks a little better. I do want it to still fit inside my part. Because again, I don't want to mill through the edge of my case, just kind of the center portion of it. Yeah, try and center that a little bit more. That looks okay. Again, I don't really care what I'm engraving at this point. I just want to have something that I can use to make a path. So I'm going to extrude cut that. And again, I'm just going to go, let's say 1 millimeter into the surface of the part. And if you guys want to use, like I said, circles or squares or whatever, you can do that. The nice thing about using the text is it'll show us some of the limitations of this process, as well as kind of how we can set up our tools. So if you guys are having trouble getting something to work through there, just make a box with a pocket on it, right? Just do a circle or a square cut into the top of the part and you should be fine. Anyone need more time to get like something drawn in on their part? Here,
Yeah,
Ben.
I don't know why. I can change the text size.
Change the text size. You go into your sketch. If you go to the bottom of the text tool, there's a little option for use document font. You can uncheck that and then you can open the font and you can actually specify the height of the letters in millimeters. So I'm using an 18 millimeter tall letter. You can also just, specify how much, what font you want in general. I find that using the height of the text be a little bit more beneficial because then I actually know how big it is, as opposed to a font point, which I don't know what the conversion of font point to actual size is. Probably something in the inches. All right. Once I've got something I can engrave out, again, it doesn't need to be letters. It could just be a box. It could be whatever you want. And it doesn't have to be just cut into the box either. We could actually have, a fully three-dimensional part. With the engraver that we're using, we have a very small amount of kind of clearance we can do up and down. But if you wanted to do like, a complex curve or a ball or something like that, you could do that too, right? I'm going to go back to my CAM tools. So I'm going to go to the CAM feature tree and back to SolidWorks CAM. Now I need to set up my mill, my stock, my coordinate system. Then after that, I can start adding machinable features to this part. So I'm going to go to the mill. I'm going to double click that. It's going to load in my options to be able to select the mill that I want to use. Here I have my Nomad, so I'm going to click on that. I'm going to click select. Now my Nomad is set as my machine. Hope you guys can see that there. I think if you double click it, it will also select it. So it's either select or double click. And then once I've got that set, I need to go back and I need to say, okay, well, what do I want to use for my tools? So I'm going to go to my tool crib. And the tool crib is all the tools that the machine has access to. And in this case, this machine does not have access to these tools. So I'm going to go to an empty tool crib. I'm going to select that. And then I'm just going to add tools to this. And really, I'm just going to add one bit to this tool. We have a range of different sizes. The largest size that we have is actually I think it's a 0.125 inch diameter bit. So I'm going to convert that to millimeters. So it's a 3.175 diameter. And we have a round nose as well as a square end bit for that. So I'm going to use the biggest one just because it's going to cut the fastest, right? So I'm going to do add tool. It's going to open up my tool database. Like I say, what kind of tool do I want? I'm going to use a flat end milling bit. And then I'm just going to pick a 3 millimeter diameter one. I'm going to add that to my list of tools. Oh man, my screen resolution is not tall enough. I can't get up to the bottom of this. Can I say enter? There we go. There was a button at the bottom of that I couldn't see because my screen is not a high enough resolution apparently. If you look at the document here, you can probably see, I guess I don't have a screenshot of the add tool, but at the bottom of the add tool, there's a little button, just click OK to kind of add it in. And then I'm going to modify this to actually make it the actual tool I want to use. So I'm going to do edit tool. And I'm going to set the tool size. I believe I've got that defined. I don't have it defined out here, but I know pretty well what it should be. The diameter should be 3.175. Oh, I didn't mean to hit enter. I'm going to go back to edit tool. The length here should only be 8 millimeters. The overall length, I'm going to set to, I think it's supposed to be 18 millimeters. It is a 2 flute. Actually, that's not right. That's too short. 24. That looks about right. It is a 2 flute. And we don't really have a shoulder on here, so I don't need to worry about that. And the shank diameter should be the same as the tip. So I'm gonna make that 3.175. And that should be good. I keep hitting enter. So those should be the appropriate sets of parameters to use. There's also a right hand cut, which means the tool is going to have to spin. Because if you're looking at the tool from the top, kind of looking down on the spindle, it spins clockwise. If you're looking at it down, like the spindle is coming down at you, it's going to look like it's, wait, is it still clockwise? Counterclockwise, yeah. Yeah, because it's going to go that way. Yeah, yeah. Yeah. Yeah.
Also too, for the post processor, I follow along with
Yeah, that directory is not there. Just kind of ignore that for now. We'll come back to it. So what are you guys, what are you on?
I just have my machine and I have the Nomad selected.
Yeah, so if you're at this point where you're looking at the machine, you double click that, you selected the Nomad, and then you want to go to the tool crib, right? And we're starting with an empty crib. So click on that one. And then we're going to add a tool to the empty crib. And I started off with a 3mm. Again, I'm using a flat end. These are all different tool types, right? So I can use a ball nose, a hog nose, a tap tool, a counter bore, counter sink, but we're using a flat end mill, or I've set it up to use a flat end mill because the cut that I'm trying to do is flat on the bottom, right? If I wanted to have something that had like a rounded bottom, or I wanted to do some kind of profile, I would use probably a different type of mill. Again, the selection of the tools is another lecture entirely, right? And then I just selected the 3. And then after I selected it, I went back into here and I edited the tool to actually make it the same size as the tool that I want to use. So all the ones in that previous list, again, are standard tool sizes. And you can use kind of one of those tool sizes to run the activity if you want. It's not going to be that big of a deal. But if the tool size that you say you're using and the tool that's loaded into the machine aren't the same, it's not going to cut properly, right? If the tool you say you're using is bigger than the tool you're actually using, it's not going to remove enough material. If the tool is bigger than you said it was, it's going to remove too much material, right? And again, if you wanted to, you could take advantage of that to some extent to oversize or undersize your parts, but probably you don't want to do that. Probably you want your tool in the machine and the tool in the actual simulation to match up, right? And you can kind of see how that looks inside here. If you want to change the spindle, you can change that too. I'm not going to mess with any of that right now just because we'll run out of time, right? Here, the post processor. So it's in program data, SolidWorks CAM, post, which is exactly where I was looking before. I didn't see a post folder though. Let's see here. Let's go to, wait, program data, SolidWorks CAM. Can I just copy this directory? I bet that it's just a hidden directory because of the way this computer is set up. And that's why it's not letting me do it. Did it find any of these ones? Program data, I'm gonna do right click, open file location. Aha! Do I dare go back to the C drive to see if this exists now? I'm gonna try it. Nope, it doesn't exist. All right, I'm gonna go back. So copy the directory from there.
the entire
Yeah, C up through post. And then inside a window, paste that in, hit enter. It'll take you to the install directory. The program data folder is hidden from us inside this current install Windows. And since we don't have admin privileges, we can't change the view properties to show hidden folders. So we're going to get around that by going directly to this folder in the SolidWorks direct install. And then we'll put our Carbide files in there. So I'm going to copy this and I'm going to go into here and I'm going to paste them. How did I get this folder to show up? Oh, go to post processor. So after you've double clicked on the machine. So I haven't really closed this after double clicking on the machine, right? I've had it open the whole time. And then I'm going to come into here. I'm going to browse and I should be able to find my Carbide now that I put that in there and we've loaded in, right? And actually those other files are loading in kind of some of this other information here. And this Hawkridge Systems, that's the name of the company that actually made the SolidWorks CAM post processor for the Carbide. And they did that out of just like, you know, hey, we made this thing. You guys want it, I guess, which is nice.
Are we copying the Carbide files or are we?
Yeah, you're going to copy the files from the zip folder that's posted on Canvas into the folder that is the SolidWorks CAM post mill. Then after you've copied those files over, come back into your post processor inside SolidWorks, click on Browse, find that Carbide 3D GRBL, and then hit Open. And then it's going to load that in as your post processor. Now that we've found that directory, you could also go back into your technology database and set that as the post processor for this machine. And that'll make that the default post processor when you load the Nomad 883. So you don't have to go in and set this every single time you make a file, right? I don't know how many times you guys are going to be doing this. Probably you're never going to run a different machine on these computers, right? But again, you know how to do it, at least to some extent. The posting here lets you set some parameters that, again, you are not going to control inside the Carbide. We don't have coolant. We're not going to really mess with offsets, but you can change like the different setups. There's a lot of different tools for how you're going to set up the machine. We're not going to mess with any of those. So if you've got your machine set up, you've got a tool defined in your tool crib, and you've got your post processor set to the Carbide 3D, you're set. If you guys want to use a different size tool, we do have different bits in, I think, 30-second increments from 1 32nd all the way up to an 8. So if you want to use a smaller bit to get more detail, feel free to do that. We also have engraver bits, which are like really thin, pointy bits, as well as a ball nose bit. So again, if you're thinking about trying to make something cool and you want to play with that, feel free to talk to me after class. Any questions about the setup there?
Getting an administrative error, trying to copy.
Are you copying and pasting, or are you trying to drag and drop?
The wrong one. I was trying to.
Yeah, so don't feel bad. I was trying to drag and drop. I called IT for them to give me admin to log into the machine remotely to type in their password to get admin privileges. They copied and pasted it, and they say, well, we didn't need admin privileges. So I'm like, well, okay, I didn't know that copying and pasting and drag and drop weren't the same thing, right? So yeah, I don't know. Just however Windows interprets that. All right, I'm gonna hit enter. You guys should have an OK box at the bottom of that screen, right? You can hit OK or you can hit enter. That'll set up the machine. So now we have a machine set up. We haven't done any tooling yet. Yeah.
You went up to post when you were searching for that file.
To find
To find like the folder that it's in, you went only up to post for the entire thing. Is that matching this?
no, post and mill. So if you get here and I copy that directory and I go into my SolidWorks thing and I hit paste or Control V, then it should come in. Although if you paste in up to post, it should still show up.
Yeah, I gotta just post and then you go to.
And then you go to mill.
My folder just says, and then M3 access to
So you copy this directory. Yes, copy. Yeah, so we're not searching for that directory, we're just going to that directory, okay? All right, now we've got our machine set up. Luckily, most of the work after we have the machine set up is done by SolidWorks for us, right? So it's kind of like on the Cura side, once you've got all the settings for your slicer kind of configured the way you want them, the process is fairly automated. I'm gonna caveat that with you can't trust the output of SolidWorks through all these automated steps to actually give you what you want, because it's going to try and figure out, hey, I have all these tools, which tool and which operation is best going to give me this geometry, that one, right? And a lot of times the that one doesn't work, right? So you have to kind of go back and say, no, that's not going to work. Use this operation instead. I want you to mill this instead of drill it, or I want you to use a facing operation as opposed to a roughing operation. We're not going to go into all that. We're just going to go through the basic pipeline and how you guys can kind of tell whether or not your stuff worked or not. What I would suggest that you do, unless you decide that you really want to learn this stuff in detail and become a machinist, is modify your geometry and your tool to get the automated process to work as good as you can for now. And then if you want to do a deep dives into each of the individual kind of machining operations later, feel free to do that. Does that make sense? So we're going to use the automated, and if the automated works, great. If not, we're going to modify the tool that we're using, or we're going to modify our part to give it more room to be able to make that operation happen. Does that make sense to everybody? So like in this case, if it didn't work because my letters were too small, I would go back and make my letters bigger, or I would make my tool smaller and then rerun the whole operation rather than trying to find a separate machining operation that fixed it. Okay. All right. Did that give you a little bit of time to catch up, Sam?
Yeah.
Great. All right. So let's modify our stock. So I'm going to double click on Stock Manager. It is going to try and make a stock that fits around my part. So this first option right here just says, hey, I'm going to make a square block that's as big as your part. So total length, total width, total height, with no overlap, or with 100% overlap. What do you want to call that, right? So the edges of my part and the edges of my stock are exactly aligned, which most of the time works out fine. I don't want to make this aluminum. My phone case is not aluminum. The material does matter. It will set feed speeds based off the power of the machine, the size of the tool, the maximum feed rate of the tool, the material you've selected, and the type of operation that's being performed. It's doing a lot of calculation in the background. So make sure your material is set to something close to what you're doing. I'm going to set mine to nylon. I actually don't know what my phone case is made out of, but it's some kind of plastic. So I'm just going to use nylon. I don't think this is actually as tough as nylon, so it probably will be a little bit conservative if I pick nylon. And then I'm going to click on OK. Again, as long as your stock is larger than your material, or larger than the thing you want to cut out, right? And the appropriate material, then that's fine. You don't want the stock to be bigger than what you're cutting out. Keep in mind that if I have stock that's larger than my part, it's going to try and cut that part down to size. So actually having stock that's smaller than your part, if you don't want to cut out the full perimeter of the part, is okay. Making it too big is bad because it's going to try and mill out all those operations. You can go back and say, hey, I don't want to do those operations, and just delete them, and that'll be okay. But it's going to add more workflow for you. So any questions on the stock? Is that all set pretty easily? Yeah.
So what is the stock?
That is the piece of material you're starting from before you do any milling operations, right? So it's a piece of wood, it's a piece of metal, it's a piece of whatever, right? It's a piece of foam, it's my phone case, right? And if you want to, you can actually have stock that starts off as a SolidWorks part. So if you have like stock that has like some curved geometry or something, right, that you're starting up with as your blank, you can load that part in and have that be the stock. And then SolidWorks will say, okay, what's the difference between the stock and the geometry I want for the part? And it'll find an operation that do just that, right? So again, you can get complicated. Most of the time your stock is like a rectangular block to start off with, right? So that works out good for most of the stuff. Again, obviously my stock is not a rectangular block, but it's close enough, right? Like I'm not going to mill out the external portions of the case. I'm just going to do my name. Make sense? All right, I'm going to set the coordinate system. The coordinate system is important because you need to make sure that the coordinate system you define in here matches the directions of the coordinate system for your machine. Most of them, X left and right, Y back and forward, Z up and down. I'm going to set my origin as the bottom left-hand corner of my part. You'll notice that my Y is not going in the right direction. So I'm going to specify the X axis to the right, the Y axis to up, and then I'm going to flip that, and the Z is upwards. You guys all see that? Extremely important that the direction of your axes are set to match your coordinate system. And the default will be to have it match the directions in the SolidWorks coordinate system with X, Y, and Z. So if that already lines up, you don't have to just define the axes. You also never should need to define all three axes. You should really only need to define two. The third one should be orthogonal to those first two with the right-hand rule, right? That is very important. I'm just going to say that again. Make sure that your origin for your part is set up in the appropriate location. Now, I am going to zero my machine to that location. So when I start the process of actually loading the part into the mill and running that, I am going to make that the 0, 0, 0 location before I hit run on the mill, right? So I don't have to have that be the center. I can have it be wherever I want. I just need to make sure that I'm going to zero my mill at that spot. And I like using the bottom left-hand corner because if you always use the bottom left-hand corner, you're always using the bottom left-hand corner and you don't have to worry about where you should zero the part out to. Whereas the middle of the part is a little bit more arbitrary, right? But again, if I was doing something where I wanted to just like write my name on the center of a big sheet and it was hard for me to find the corner or the corner was going to come off the side of the engraver or something like that, I could put a spot in the middle of where I wanted to engrave and I could make that the origin. I could zero to that spot and then my engraving would be relative to that initial position. So you might want to start someplace else. I just always like using the corner. That kind of makes sense, everybody? A little bit, maybe?
You just go over that mixture.
Yeah, so I just double clicked on coordinate system. So from the, this is still inside the display manager, the CAM display manager. Yeah, just double click on coordinate system and then you want user defined, right? And then you can click on any point. So I use the vertex for the corner and then I use these lines on the side of my box to define the X and the Y axes. All right, now I've got that defined. I want to extract the machinable features, develop an operational plan, generate tool path, simulate tool path, write the tool path to a file, and then I can take the file over to the machine and actually start milling. We're going to try and go through this pretty quick just because I want you guys to actually see the mill run. If we have time, we only got 15 minutes left. So I'm going to extract machinable features. It's going to go through all the features inside my geometry and then say, hey, I can make this with a blank. Okay, this next feature. Hey, I can make that with a blank. Okay, next feature. So you notice here that all of my features are irregular pockets. They're all just pockets and none of them are rectangular. That's why they're irregular, right? So this is all the features. Again, if you have geometry that didn't get extracted, it'll give you an error. You can go back and you can say, okay, well, how come that didn't give me a geometry? What can I do to make that bigger or use a smaller tool or whatever to make something that it'll recognize? Once I've got my features, again, I can check and make sure all of those look like they're what I want, right? You can kind of see the overall outlines. I can generate my operational plan. Yeah, Will.
Does the order case?
No, it doesn't. I mean, you can reorder them if you want.
I mean, I was gonna ask why it shows. Is the
It's
order
arbitrary. Probably the ultimate, and you can change the order if you want, like I can rearrange them, right? And it probably makes sense to put them in order, although it's not going to make that much difference in total machining time. There is a sort function that you can do later on, especially if you're doing machining operations that have multiple tools to prevent tool changes, right? So if I want to do all my roughing with a larger bit and then you go to a smaller bit to do the finishing operations, which is a very common thing to do, right? I can set it so that way all my roughing operations go first and then all of my finishing operations go so that I don't have to do as many tool changes to save time on manufacturing. The default would be for it to do each feature all the way through and that'd be a lot of tool changes, right?
When you were setting up the tool, as far as like the machine ladder,
Yeah.
what would be the difference with one to two tools?
So for ours, I've only set up one tool, so there's no tool changes. When you have multiple tools, SolidWorks will pick the best tool for each operation, right? And so that will require tool changes. On this machine, you have to manually change the tool. A lot of automated milling machines have a tool crib, which is why it's called that on the system, where it'll actually go and automatically change the tool as part of the manufacturing operation, right? In which case, again, you don't have to do a whole lot, which is nice. All right, now I've got all of my features. I need to generate an operational plan. I haven't done anything here. I just clicked on this button. Now I'm clicking on this button. That's going to go through each of those features and say, okay, that is an irregular pocket. I can cut that with this feature or with this kind of machining process. So I'll use a you know, a roughing pass, and then I'll use a finishing pass, and maybe I'll do multiple roughing passes and then a finishing pass, et cetera, et cetera, et cetera. While this is generating, I do want to make a note here. You guys want to see where it says mill part setup 1. If you have multiple setups, that means you need to take the part out, reorient it, and then bolt it back down, right? That makes it take longer to make that part, probably obviously, right? So if you can set your tooling up so you only have one setup, that's going to be better. And honestly, it's really hard to get the part in the exact right position when you reorient it like that. So if you can avoid those reorienting processes, it saves you a lot of time. And if you're running a 3-axis mill, that's going to be the majority of your labor is loading in the stock and reorienting it. And again, also the majority of the variance in your parts is it not being put in exactly the right position after it's been reoriented, right? Is this still running? It's still trying to go. We're just going to wait for the command to finish. I'm going to be patient. It does take it a while for me to do this. I probably should have just done Derek instead of Derek Lyra, so it would have had a lot less features to extract. The fewer kind of depths of cut you have, these ones are all independent. They're not a continuous pocket. Then the less features you're going to have and the less time it's going to take for it to generate these kind of profiles. There we go. It finished. All right, so first thing here, we've gone from my CAM manager to my feature tree. So you guys, you have a display manager, the feature tree, you guys see those 2 check boxes at the top. My pockets in my setup have all turned black. That means that each of those pockets has a defined operational plan, right? And so you can see all the operational plans here, and I can see actually what each of those looks like if I click on them. And you'll see for each of these, I have a roughing pass, so 2 roughing pass, and then a contour, roughing, roughing, contour, roughing, roughing, contour, roughing, roughing, contour, roughing, roughing, contour, right? And again, I can sort this out. This is not the actual toolpaths, but this is the process I'm going to use to generate the toolpaths, right? Again, that's the next step is to generate the toolpaths. So you can go through and look at these and try and make sure that they are the operations that you want. If you say, yeah, that looks fine, or if you don't know whether or not that's good, the next step is to generate the toolpath. If you see something that you don't want, then you want to go back and either redo this whole process or manually modify the operations, right? Which again, you can manually define operations up here if you want. And just like you can go back and do this one here, and I can manually define features. In this case, all my features are defined, so it doesn't really want me to. I'm going to generate toolpath. It's going to try and machine all of these parts. It might not do all of them. So on all of my letters, it actually has 2 roughing operations. It may decide after the fact that it doesn't need to do both of those roughing operations. And when I ran this last time, it did that because it knows that it's not going to be able to get the corners of all my letters with the larger bit. And so what it's trying to do is say, hey, I'm going to use a big bit to do my initial roughing, right? And then I'll use a smaller bit to do a smaller roughing, and then I'll do a finishing operation. But because I don't have multiple tools in the crib for it to pull out, it just said, okay, well, I'm just going to do the one operation, and then I'm not going to do the second roughing, and then I'll do the finishing, right? And you see we got largely the same thing here. The contour milling didn't go. What I'm going to do is I'm just going to suppress these operations that didn't finish. I think I should be able to. No, I don't want to delete. I want to suppress. Can I shift click or control click these? Yeah. So I'm going to click all the ones that didn't run out. Oh, that didn't go at all? I may try to regenerate that path. And I'm going to suppress these ones. I want to make sure I have at least the roughing pass for each of my letters. So I may try and regenerate just this one piece. I'm suppressing the ones that are blue here that are underdefined. And I'm trying to see what I have left after that, right? So here, I've got the roughing pass for my E, a roughing pass for the other E, a roughing pass for the K. The roughing pass for the U didn't work. That should be like the easiest one. So I'm gonna try and generate a toolpath for just the U. Still didn't work. It's blue.
So if everything's blue,
If everything's blue, then it didn't generate any toolpaths for you. How come we're not able to get a toolpath for that U?
If everything's blue, you have no toolpath.
You have no toolpaths. Yeah.
Yeah.
How big is this U? It's big enough. It's 3.2. I wonder if this curvature on the bottom is too tight. I'm gonna cheat. I don't want to rerun all of these. You know what? I think I'm just gonna do I'm gonna suppress all of my LURA ones. I'm just gonna do just the Derek. Because we don't have time to go back. I could go back and I can make the U a little bit bigger. Or I could go ahead and change my bit to make it smaller. I think that the U is just a little bit too small on the curved portion. Probably the gap between like the inner curve and the outer curve is too small for the roughing optimization for that to work. I'm just going to suppress all of these ones that are part of my LURA. And I did use the largest bit that I have. Well, that's interesting. It actually generated a facing operation on top of the E. I don't like that. Oh, well, let's see. So there's my D. There's my R. There's my E and my K. So I've got the Derek at least planned out. So once you've got your path set out the way you want them, the next step is to simulate the machining and see if it actually looks like what you want. So I'm going to simulate toolpath. If you guys think any toolpath, just watch along because we're kind of out of time. And I'm going to run this out. You can see it's going through and it's machining out. Why did it do just that? That's weird. It doesn't think that my letters, my letters are all too thin. It didn't do any of the passes to pull those out. So I can actually look at this and I can change the display. And this is the error of my machining process. The blue means that it is undercut. The red would be overcut. And you can see that it didn't actually cut out any of my letters. I'm going to go back to my part and just make it bigger. What I should probably do is I should go back and swapped out that bit for like a quarter, a 3/16 or something, and use that. But I'm just going to do my extrude cut here. I'm going to edit the sketch. I'm going to make my lettering just a little bit bigger.
I tried doing that and it's still showing letters.
You're going to have to delete your previous setup. So I'm going to make this 20. And I'm going to click OK. I'm hoping that's enough bigger. If I go too much bigger than that, actually, let's do just Derek. All right, let's do this. Let's do Dr. D. Can I do a period? I don't really care if the period prints or not. Let's make it 25. We'll get extreme with this, right? Accept. And now I'm going to go back to my CAM operations. It's going to try and rerun all of these. I don't think I'm going to want to do that. I'm actually going to just delete my whole setup. So they're all in the trash now. And then I'll redo extractable machine features. Should go a lot faster because now I have way fewer pockets. How come I didn't even find anything? That's no bueno. Coordinate system's the same. Part setup's the same. Is it putting it? Oh, they're in the recycling bin still. All right, I'm gonna try to recover these. I'm gonna restore the ones that are for my letters that are still there. DRD, the period. So apparently I deleted all of them and it had already regenerated parts of those. So I needed some of those. I'll do my operational plan. I think the period it might have a problem with, but again, if it doesn't generate that, I'm not that worried. Let the load. No, we need more class time. Come on, SolidWorks, you can do it. Well, the last thing we do after we have the simulate the toolpath, we would post process. So I got that set up, process that. That looks a lot better. Again, simulate the toolpath. I'm running critically low on resources. Run the simulation. That is a really bad toolpath. I probably would take off that operation if I was trying to get this to actually work. That path is real bad. And it's probably that second roughing operation that I just don't need. I'm also not sure. Oh, it's like doing like a pecking operation. I don't like that at all. I'm going to ignore it though. I got that. So these roughing operations here, you see it's doing that pecking. You can see all the vertical lines. That's no good. Suppress. Suppress. That one didn't have it. That one's got it. Suppress. That's much better. And then I can post process. Again, I've got this Carbide thing set up. I can save that to a thumb drive. And then I think what I'll do is I'll record a video of this setup and the running so you guys can go to your class and I'll post it up on Canvas. That sound good?
Do you want a submission for today?
Yeah. I mean, just put something right onto a part, set up a tool path. I don't care what it is, and send it to me, right? And then if you want to get something more complicated that you want to, actually engrave something, then let me know.
What do you mean by saying what kind of tooling you want to use?
So just if you have a part that has the machine code set up, right, and the tool path set up, post-process it, save it as an NC file, and then submit that to Canvas with your part file. So if you look at the assignment for today,
The NCC file or .NC?
yeah, the .nc. I want the part file, the G code, which is the .nc file, right? And then just a brief summary of what the engraving is supposed to be for. Again, if you don't want to do the summary, you guys don't actually want to engrave it out, then I don't need that as much. But if you actually do want to engrave something, let me know what you want to engrave. And then if you do want to engrave something, bring me the thing you want to engrave, right? This is not necessary, this is optional, right? But these first two parts, the part file with the CAM data and the G code, please submit those. Again, just sometime today.
I think still these are good. Is that okay?
Uh,
I think Will had it. It was like all three.
Well, I agree.
Yeah, if you click on this little button right there, that is the error between the actual part and the machine piece. reason it's overcutting, it's cutting that out. I don't know why. If you go back to your, you may have an operation look at the bottom. Yeah, you still have operation from your previous run through. Does that make sense? So if you just find the one that is that part and suppress or delete it, it's fine. Yes. It's still not working.
Yeah. It was after,
Like halfway through.
yeah.
Yeah, I keep.
How do you go from this to actually?
Yeah, so here, the last thing I'm going to do on this recording is save this to a file. So for now, I'm just going to put it on my desktop. And then all I do is I load this file onto the Carbide in the control software for the engraver.
There's not a separate slicing software.
No, so all the machine code, right? The G code is generated here. And then all I need the software to do is to run the machine, right? Well, and also to set up all my zeros and stuff. But I'll make a little video of that and I'll post it up on Canvas. I wonder if I should like swap out for a smaller bit and then run that. Yeah, let's pull this out. And put this on the list. All right, I'm going to stop recording, and again, I'll have the other video posted up sometime later today.